A question very frequently asked on the forums is, what are sine and cosine and how are they used? So this video is just going to very quickly look at each of these and what they do and how we can use them in our games. All we're going to be doing to start with is we're just going to take sine, self-time. It doesn't really matter which you use of self-time or game time. There are implications later on when it gets a bit more complicated, but they're nothing we need to worry about now. I'm just going to display it using this display text behavior. As you can see, what's happening is this number is very slowly increasing from 0, and it will keep increasing until it reaches 1. It's happening far too slowly, and there are lots of trailing numbers. So I'm just going to only show the first couple of decimal points, just to make things a little bit simpler and a little bit clearer. You see, it's still increasing very slowly. Now, the first thing we can do is we can increase the speed at which it increases, and we can do this by multiplying self-time by the amount we want to increase the speed. So if we increase it by 10 to 10 times as fast, we'll see it's increasing much quicker. And if we give it a few seconds, it will increase all the way up to 1, slows down as it reaches 1, and we'll see why in a few minutes, and then it works its way back down to 0. When it gets to 0, it's not going to stop. It's going to keep going until it reaches -1. And so that number is now going to oscillate between 1 and -1, 1 and -1. Now, we can in fact add one more condition and increase the amount that it's going to multiply by. So now, instead of going from 0.01 to 1, it's going to go from 1 to 100, and then back down until it reaches -100. We'll see what impact these things have in a moment. We're going to just turn that off and the display text off now, and we're going to look at an actor and the effect that it will have upon it. If we look at this particular formula here, we can see we've got 384. This is the starting position. This is the point you want the middle to be at. So 384 is where the number is going to reach the centre. It's going to be going below and above 384. We've got 100 times the speed that it would do by default, and we've got 200 as the amount that it's going to go above and below the number 384. So if we preview this actor, you'll see it just goes from side to side. It goes to side to side. If we add a motion to the actor as well, it's going to keep going side to side while also moving downwards, and we get this swerving, curving motion. If we add the trail, which is just spawning an actor constantly, you'll see the motion, the path that it is followed as it goes down. Now, if we wanted to have it travel less distance, so it's travelling a total of 200 pixels, if we wanted it to travel less distance, we just decrease that. And now it's going to travel a much narrower path because it's only going that 20 pixels. If we want to make it do the same long path but go much slower, we can just reduce the amount we're multiplying time by. Now, because we're moving down at the same speed, the loop is much larger and longer and wider, but the same amount of distance is being travelled from side to side, as in the first example we saw. If we go back and look at that first example again, that same amount of distance is being travelled, it's just doing it much faster, so it's doing much more of the loops, of the zigzagging, than it does if we slow it down. Now, the exact same works on the y-axis as well. If we look at this one, we're starting at 512, which is the centre of the screen. We're using cos here. You just want to use the opposite one. It doesn't enormously matter which one you use. There are differences, but they're very minor for these basic examples. Again, 100 times the default speed, moving 200 pixels. And we'll see it goes down and back up in exactly the same way as we saw it go side to side. If we then add the motion, this time we're moving it to the right, we'll see it does the same up and down oscillating pattern that we saw before. Now, we mentioned earlier that it slows down as it gets closer to its upper and lower limits. And as you can see, that's because when it comes to these, it's taking this curve, it's having to go all the way round rather than just going in a straight line there. The maths behind that is very complicated. I'm not even going to try and go into it here. If we want to do one more change, we can enable both of them at the same time. And hopefully you'll have guessed that if we're telling it to go to the side and to go down at the same time, at the same rate, what we end up with is a circle. And it will keep spinning round and round in that circle. If we want to change the shape of the circle, let's say we want to make the circle a bit wider, we just change the distance it's travelling on the x-axis, and then the circle has become wider. If we want to make the circle a bit taller, we just change the distance it travels on the y-axis, and we end up with a taller, more oval circle. And that's pretty much it for a basic explanation as to what sine and cosine are doing. There are enormously complicated and powerful things you can do with them. They are horrendously helpful in GameSalad, and I'll consider perhaps looking in more detail at some of the effects you can create with these in another video later.